Hi, welcome. Come in, come in, come in. It's a full house, I see. We're gonna start in a minute. Just take your time, be seated. I know you're ready for a deep dive, so take a deep breath, close the door. We're gonna start in a bit. So I think we can start, and I'm gonna introduce myself. So my name is Spiros Athanasiou. I'm from the Athena Research Center. I'm here because my role in the EOSC EU Node is the account executive. Essentially, I'm coordinating the service provision of the EOSC EU Node on behalf of the contractors. We just launched yesterday. I hope you had a chance to visit the site, check it out. Hopefully, you had credits. We will dedicate this session to do a few things. First of all, I am going to give you a very brief rundown of the basic concepts of the EOSC EU Node. We will see a short video that is also available in our booth outside, and then I will give the floor to two scientists with early access in the EOSC EU Node. And they will tell us about their experiences on how they used the services in their own specific fields. Then we will have a short presentation from a research cloud offering similar services to the EOSC Node. We're interested to see how exactly these can be complementary, can build on each other, integrated with each other, and then we will continue with a big Q&A session, 30 minutes, both from the audience over here as well as our participants over the web through Slido. We will try to answer as many questions as we can, right? I will try to limit the scope of the questions in the specific concept of the EOSC Node, not the federation, not policy decisions. That's another topic, that's another session, right? So apologies for that. Now, I would like to formally introduce our panelists right now because I'm definitely going to forget it later. First of all, I want to thank them for the work they've done over the past few weeks, having access to the staging environment of the EOSC Node, helping us to identify issues, challenges, improve the service in general. So, our first panelist is Sandra Diaz. Sandra is she's currently the scientific leader of the Simulation and Data Lab for Neuroscience in ULIC. Her research focuses on high-performance computing, simulation of brain dynamics and plasticity at different scales and optimization. She has participated in several EU projects, one of which has also been referenced yesterday by the DigiConnect, the Human Brain Project. And I've had the pleasure and privilege of working with Sandra for quite some time in this specific initiative. Moving on, our next panelist, Angeliki Adamaki. She's a scientist and project manager in the ICOS Carbon Portal and on the University of Lund in Sweden. For the past 7 years, has been working on European project with particular interest in open science practices. In this panel, she represents Homeros, one of the Oscars-funded projects that aim at strengthening multi-hazard assessment using open science. And she is also involved in the EnvriHub Next and IRISC projects. Finally, our next panelist is Invar Janmat. He is a manager at the SURF Research Cloud at SURF. The SURF Research Cloud provides several services, virtual machines, cloud environments, access to HPC services across the Netherlands. So we will also have a chance to see how these two services, the SURF Cloud and the EOSC Node, can be used in practice together. So, with that being said, I'm going to start with my slides and I'm going to start moving a bit. So, let's move on. A brief introduction about the EOSC Node. You might have heard about this in the technical launch in the past few days, but I want to emphasize and highlight a few things. So it is the first node of the EOSC Federation commissioned by the European Commission as the business owner and managed by the service contractor. So it has an owner. It's the European Commission. It is a commission service. It provides access to multidisciplinary, multinational scientific data. It is built, provisioned, and operated, leveraging all the experience and outcome gained from several EOSC-related projects in the past. The difference, instead of focusing on innovation and research, we focus on operations and quality of service. It serves the EOSC node as a blueprint for other nodes, so the architecture as well as the open source software. That's it. Every EU node has full autonomy in terms of what services they provide. It offers federating capabilities to other nodes, for example, the AAI variant or software as a service, such as the help desk. What we serve, the EOSC node serves researchers and research groups across disciplines and in many cases underserved from their specific communities, RIs, or whatever, the long tail of science, as well as citizen scientists. We also serve service providers, so organizations, RIs, other nodes that want to provide their services through the node. And currently, it is the focal point of the federation, but it's just the first node, nothing more than that. You can see the contractors in this slide. I'm from the Athena Research Center. The exchange and application services, virtual machines, Jupyter notebooks are provided by PSNC and its subcontractors. We will not go through the architecture. It doesn't make any sense. You will have the chance to go through it if that's your interest. Now, a bunch of key concepts about the authentication. So, we have no registration. You don't have to create yet another account. You are a researcher, you come from your university, research center, you come with your own credentials. That's it. This is a seamless experience, and what happens if we have set up the EOSC AAI Federation? Currently, we support EDU Gain, so this means that most probably you already have an account that is compatible, as well as EU Login with EIDAS, the Future Identification Scheme. Again, pretty much everyone can get access to it. What happens in the background is, through the home organization, your university will get your attributes, where you are from, your country, your affiliation. And this is what allows us to know who you are and build on that. Further, we offer single sign-on across all services, and this EOSC AAI is offered as a service to other nodes and the community at large. So it doesn't matter if you have a node or a service or whatever, you can use the EOSC AAI. Moving on. The service tiers. Services. So we have 3 different tiers. What we call is Tier 1, the native services. These are the guaranteed services of the EOSC node. These are procured by the European Commission. The virtual machines, the file sync and share service, these are integrated in the user experience with automatically applied access policies and quota for the services. Then we have the Tier 2 services. These are coming soon. It is part of the onboarding, right, as you may remember. The definition is high-quality third-party services onboarded into the EOSC node with a specific level of technical and operational requirements, of course, quality assured, with service-specific ordering, access policies, and/or integration options. Finally, we have Tier 3. These are just discoverable services, services you can just find in the Research Hub. There are no technical requirements, and the whole concept is to enable the discovery of the services even if they're not in a mature level to become operational. And as you can see over here, we have essentially set up a progressive scheme, starting from the bottom, the lowest possible effort and cost to have your service in the EOSC node, up to Tier 1, the highest possible, with the highest possible quality. Moving on, you have been introduced to the concept of credits, and we hear quite a few questions about what these are, what they're about. So, we had a challenge. How do we manage the user demand for all these services, the application services, the exchange services, in a fair, equitable, and transparent manner. We had a finite amount of resources, computer storage resources. We need to share them. What happens is we have introduced the credits, the virtual currency of the EOSC EU Node. These express the relative as well as actual cost of services, virtual machines, for example, but have no monetary value. They're not euros, they're not pounds, nothing of the sort. Users are already familiar with this concept of credits in many services. Every service has its cost expressed in credits. So, for example, users know how much and in advance a virtual machine will cost per day, how much storage costs per month. When a user first joins the EOSC EU Node, they are given free credits in their own personal wallet. So I enter as a university professor and I get my free credits, which I can use however I want. The same amount of credits is given to all users of the same category. And these are replenished every 3 months so that you know whenever you come back, your credits will be replenished and you can do something. It is important to mention that this whole credit economy, so how much a service costs, right? How many credits we give to users, this is meant to evolve in order to support user needs as well as service providers. Now, how to build everything under the access policies? Now, authorizing the users to spend their credits on the EOSC Node is an automated process based on their affiliation. So I am authenticated with my home organization credentials. We can see your role, your affiliation, your country, and this is how we give you credits, and this is where we allow you to spend them. So we have 3 levels, what we call access policy level B. If you're a faculty in any of European Union countries or an Horizon Europe associated country, then you have 500 credits to spend and access to all the services. If you are an employee or staff in an EU GAIN organization, again, European Union or as an associated countries, you get, or EU login, you're a member of the Commission, you get 100 credits and access to a subset of the services. And for all other cases, you just have view access to the services, which is important because having view access, you cannot use them, but you know they exist, and someone else can invite you. A member of your group can invite you, so you can start using them as well. Of course, there are some what we call gate-kept services. So these are scarce services or in high demand, such as GPUs, right? You have to ask for accessing these services. And just to mention it again, these access policies can be revised. The important thing, and it's really important to stress right now, is that these are automated. There is no human involved. Moving on, about the specific features and services of the EOSC Node, I'm just going to run through it. I'm pretty sure we had the chance to go through it. So we have what we call the front office, your entry point, and here you can find links to what we call the application services, the infrastructure services, accessing the help desk, the FAQ, which is already an important source of information and will be enriched with your questions and answers. You can find access to documentation as well as training material and a link to the user space. The Resource Hub is essentially a search engine, already indexing close to 130 million scientific resources, publications, data, software, right? These are the kinds of resources. Moving on to what we call application services, the file sync and share, your own cloud storage, interactive notebooks, Jupyter technology, so you can run across different environments, as well as large file transfer for securely sharing files between colleagues. Then we have the lower level, the infrastructure services. These are virtual machines based on OpenStack. We have the cloud container platform based on OKD, as well as bulk data transfer for site-to-site large data transfers. So pretty much with these services, you can deploy whatever software you have available, because I'm pretty sure OpenStack, OKD are the standards you already use. How you log in? You press login, you select your home organization, and the access policy is automatically applied. You don't have to do anything. This is the user space, right? Your own personal environment where you can see your application services, requesting access to them, your wallet, your orders, the groups, because you can create groups and share resources with others, your favorites, settings, etc. And now what we can do, and this is the final slide, we can continue with the video, the short video about the EOSC Node. This is exactly the same video available in our booth, but because I'm pretty sure you haven't had the chance to see it in action or visit the booth or whatever, we're gonna watch it, and I'm gonna be asking, if relevant, to pause for a sec. So this is just the help desk, a page for the contributors, the news, pretty basic stuff so far. The resource hub, where allows you to search and view and filter publications, data, software, and visiting the user space. Over here, you simply select your home organization. This is the test identity provider. You log in using your home organization credentials. You visit the user space. We can see your settings. You can evaluate where you're from, your specific settings. We already have credits, 500 in this case, to spend. This is the file sync and share service. We are requesting access for 2 months. We get a quote, it costs 20 credits, that's fine. We get the environment available, and now you can see, oh, we have already shared the resource, it has been accepted, this is my own view, and I can create something, a folder within the user space, or I can open the dedicated web client from OnCloud, which is the provider. Same thing with interactive notebooks. We have 3 different environments. I have just requested a small environment, and I'm gonna start it right now. It's just a notebook. The resources have started. I'm gonna view the environment externally. So the Jupyter environment has started. We are redirected, single sign-on, and I execute whatever I want. Same thing with a large file transfer. I get access and everything. The reason we briefly view this right now is because the demonstrations of our panelists take the next step. After we have had access to the notebooks, to the file sync and share and services, they will show us what they did with these services. So with that being said, I'd like to invite over here on the floor our colleague Sandra Diaz. Sandra, this is the clicker.
Okay, hello everybody. Thank you very much, Spiros, for the invitation. I'm really excited to be here today and share with you our early experience with the EU Node. This is a very exciting time of getting more and more access into increasingly high intensive computing resources, and we know that this is an essential step for science to move forward. So I am really happy to be here today and share what we did. As Spiros mentioned, we had a quick run into the early service launch of this platform. So it was quite an interesting experience and very, very exciting and glad to share this. As Spiros mentioned, I come from the Forschungszentrum Jülich. My group is the Simulation and Data Lab, Neuroscience, and we are actually in the middle between the neuroscience community and the high-performance computing infrastructure that the Jülich Supercomputing Center provides. And this means that we are a highly community-oriented group. We try to develop methods and research services that allow our users to make the best out of our high-performance computing infrastructure. It is interesting because neuroscience was quite away from high-performance computing about 10 years ago, the Human Brain Project had a big impact in moving neuroscience closer to HPC. And today, thanks to the large collaborations that have emerged Europe-wide, neuroscientists have started to really make a lot more use of this type of infrastructure in a more formal manner, and we are very happy to be part of this effort. As Spears mentioned, we have worked together in the past to also take the community in that field. And here, when I mention the neuroscience community, I really want you to think that it is not only about the experimental neuroscientists. We really cater for a very broad range of users, going from the experimental neuroscientists taking tissue samples and looking into what neurons do, all the way to engineers trying to design the new technologies for computing with neuromorphic compute, or developing new algorithms for bio-inspired AI. So there is a broad range of users that we cater for. In this small presentation, I want to especially focus on simulation of the brain. In our group, we also support different platforms that allow you to simulate brain dynamics at different scales, going from the very detailed neurons with the platform Arbor, going to networks of neurons with Nest, and whole brain simulations with the virtual brain. They are used to answer different research questions, and their compute requirements are quite different. Simulations with Arbor require a lot of computational resources because the levels of detail are very high. You can imagine that each of these neurons is represented by several tens or hundreds of differential equations that need to be solved in parallel. So this is quite complex, and the computational complexity reduces as we go towards the whole level. However, with machine learning and AI coming into the field, we have found that optimization of these models is also a very interesting topic, also for high-performance computing. So today, I actually want to show you two use cases, one on the whole brain area, optimization of these models, and one on using Nest for more educational purposes. So the first use case will use the Jupyter notebooks in the platform, and also showcases something that we wanted to try as soon as we got access to the node. It was, can we connect to our HPC systems from there and launch some heavy loads into our supercomputers, and then get the data back to the node and store this data and share it with other members of our projects. And we achieved this with a combination of other tools, also Unicore, which is developed at the JSC, and Learning to Learn, which is a platform for optimization using machine learning. And the second use case that I want to show is using containers. And here we are going to launch a Nest desktop application, which basically is a user interface that lowers the threshold to access simulations of brain dynamics. I just want to briefly mention that these use cases are strongly linked to these two European projects, of which we are members. eBrain's Health, which aims at modeling disease in the brain and having a secure platform for personal data processing, which is very important in the field of neuroscience and clinical applications. And the other project is eBrains 2.0, which is the project that allows us to continue the development of eBrains, the legacy of the Human Brain Project in terms of research infrastructure. And there are several projects there that we are working on. We contribute there to software development, but also to community and development and architecture definition together with several colleagues, including Spiros. So I before we go to the videos, I want to thank my group, but especially my colleagues Thorsten Harte, Han Lu, and Michiel van der Vlag, as they were the ones who took the first dive into the platform and got into preparing these videos. So if we can start with the first video. Yes, so here is Michiel's platform, as you can see, and he's going to start a Jupyter notebook where the idea is first to set up an environment in a way that we can connect to our supercomputers in Jülich. So the first thing that he will do is have an install setup, which takes care of getting some of the basic packages that are needed, and then establish a connection with our supercomputers. Here, it's important to notice, you will see that here we have given the token. These are short-lived tokens that identify ourselves into our platform, and we have given this here manually. We didn't go all the way to testing the integration of the AI, but we hope this works quite well. We will continue working on this, but in the meantime, we did this manually to avoid problems. So basically, here what my colleague is doing is submitting a small script to our supercomputers via Unicore that allows him to run this small script that sets up the whole environment in our supercomputer so that we can send commands from the node, from the Jupyter notebook, all the way to our supercomputer. And he is here showing here the view from our supercomputer. Unfortunately, there's quite some text on the top and it's difficult to see, but he has the view from the HPC system and the node in parallel, so you can see when the job is deploying. So he launched a small job to set up the whole environment in the supercomputer, and once the setup is complete and the virtual environment is activated, he can now start submitting resources in the backend. And I think, unfortunately, the video is not very, so there is a missing line on the bottom, but the setup script is there and it has been executed, and you see that the right folders have been created to execute the load. So now this is the main target. These are simulations of the whole brain. You see this fancy tractography kind of images that come out. And the goal is, you see those brain waves there. These brain waves emerge when your brain is in a sleep state. So the goal that Michiel wants to achieve here is to launch a set of simulations of the whole brain and find parameters using machine learning, launching a job on our supercomputers, guiding these parameter search in the very vast parameter environment to find those configurations that actually show this sleep-like wave dynamics. And here he's briefly showing the optimize. This is what we optimize for. So this contains the simulation plus the parameters that will be explored by our machine learning tool. So this is quite a straightforward machine learning. This is no fancy neural network. We are here using mostly gradient-free optimization resources like closed entropy or simulated annealing. And this is the smallest script that then gets executed. So he defines some parameters and how many times this execution should take place. Once he is done setting everything, he is copying his batch script and everything that defines the amount of nodes, the account to which this job should belong to, and every specification that our SLOM system would need to execute this job. This can be done in different ways. This is just one way of doing it. You can just also use Unicore directly to launch these jobs into the supercomputer and specifying these parameters there. So he starts the job on the HPC, and waits for the job to be executed. At the moment he is sampling the queue, the the line below shows that it's waiting for resources. Unfortunately, it says CF is configuration phase, so then the resources in our supercomputer are getting configured for the execution of the job. And he's just waiting on this side. And then in the lower side, now it should turn to R, so it's running. So the simulation now is running. And it's actually quite fast. It makes a quite broad parameter exploration. And at the end, it is executing an staging process afterwards that will allow him to then finalize the results and get the analysis of the simulations back into the node. So it's a, let's say, two-step simulation setup. And when this is done, just to wait a small bit, perfect. The error is, there is no error, and the output is, there is something. So that is great. And we can now start displaying the different execution runs. So these are different generations that the machine learning tool deployed on the infrastructure iteratively to look for these parameters. So this tool provides some kind of set of parameters to be explored and does this iteratively through time. And yeah, I think in this case he used gradient descent. So we have a few gradient-based optimizations. Gradient descent is one of them. And now he is copying back all the analysis that was produced by this optimization setup. And he can now start unpickling it because he compressed all the data to be able to have this in an easier manner pushed back into the system. And now that he has done that, he can see that there's, he can confirm that the dimensions of the output are correct. And he's gonna just start plotting all the different results that he got. So here you can see the results of different simulations with different parameters. Some of them are less similar to the ones that that were looked for, and other ones are a little bit closer to what we would like to have. So that was a first sample of this, and now, yeah, these are now all the series of the different best matches that were found following the specific metrics on the supercomputer. Mm-hmm. So yeah, this was our first attempt to get a connection to our HPC systems. And I think we can cut the video here because I would like to move to the second one very quickly as I am consuming quite a lot of time now. Sorry about that. But very quickly, I wanted to show you here, I wanted to make a small experiment on deploying a service that we use to teach scientists, young scientists, how to use Nest, which is one of the simulation tools. And Nest Desktop is this graphic user interface, and it is already very well developed and distributed in the way of a set of containers. We have here two containers, one for the visual side and one for the backend, let's say the simulation side. So here I defined these two Docker containers in the description of the pod. We have one for the Nest Desktop, another for the Nest Simulator. And we can create the pods, and once they are running, we just basically need to provide some networking setup here. So we create link the service to the pods that are open from the Next Desktop. So Next Desktop is an application that is quite particular because it runs on your browser. That means that you do not have you're not seeing the application through another, let's say, remote desktop application, but you're executing the application directly in your browser. That means that in order to connect to the backend, this also needs to have a route back to the container from the Nest simulator that is visible from your own system. And this is easy to manage from the node. This was actually very nice, and it was super easy to set up. We just had to link the different ports between them. And actually, when we launched the routes, so when we set up first the services to the ports that would be connecting to, and then we defined a route that would connect our Next Desktop back to the container with Nest. And by doing this, it was super easy. Next Desktop understood directly that it should go to a specific path to connect to Nest. And it was a super easy experience. So we were quite glad with this. Yeah, so now that the service and the routes were defined, we basically just click on Next Desktop and ta-da, we have Next Desktop. And here you can see in the settings that it automatically grabbed the right path to Nest, so it's green, it can connect to it. And we can have, let's say, a small example of a neuron with a current stimulator and a voltage meter. And we can simulate it running in the node, and you see this nice membrane potential in the small neuron. And you can play with different models that are available or use your own ones. So it was, I mean, it took like 2 minutes to set up. It was really exciting and super fast. And we think this has great potential for education purposes, because this is also something that we are struggling constantly with. And this desktop provides you also with all the code automatically. So you do this with a graphic interface, but then you get also all the code, so you can continue learning how to do this manually. And yeah, we're very excited about the experience. It was very nice, and thank you very much for your attention.
Thanks so much. Angeliki, you can come. So, summary. EOSC EU Node resources, Jupyter notebooks, running, and also using HPC resources from ULIC. Then, using the cloud containers to do something relatively straightforward, but as we see, difficult in practice, just deploy an environment for young scientists to learn about neuroscience. Now, the floor to Angeliki Adamaki.
So after the fancy stuff about brains and waves, I have to talk about natural disasters. Yay. No, that's yes. So that's us. So, well, as Spiros mentioned earlier, today I represent this very Greek-named OMIROS project. OMIROS is an acronym that stands for Harmonizing Observations from Multi-Hazard Environments in Research for Open Science. And it's a project that is funded by OSCARs and is supported by the ENVI community. So the work that we did here, some small experiments that we did with the early access that we got at the EOSC EU Node, was a collaborative effort with early career scientists that work at Greek universities, and you can see their name here, and I thank them a lot for this. A few words first so that you can understand who we are. The project, scientifically speaking, belongs to the discipline of geosciences. So we are scientists from topics from scientific fields in seismology, geodesy, geology. So we want to focus on two high-risk areas in Greece, the Ionian Islands and the West Corinth Gulf, which are basically environments that are in combined risk when it comes to natural disasters. So for our research, we work with high quality data. Those data sets are gathered either by our institutions or they are combined with data from diverse sources, which are remote databases, for example, that are supported by research infrastructures. So for this particular project, we have set also some open science goals, one of the reasons we are funded by EOSC, because we want to focus on how to improve the fairness of our workflows. We would like to basically see how we can improve the way we do research, how we can create a collaborative environment, how we can support open science practices in geosciences, and how we can make, well, basically geoscience more open and more inclusive. Now that you know who we are, let me tell you what we need. So when it comes to providers like the EOSC EU Node, we would like to see services that allow us to, as I said, improve the way we do research. We are distributed research groups. We are in different locations, different universities. We are also people with, yes, scientific background, but different scientific background. We come from different fields, even though, well, someone might say, you're all geoscientists. Well, we don't speak the same language and we don't work in the same way. So we have to find a way to communicate, to have our systems communicate. And we would like to also be able, well, to combine the scientific background with the technical skills that we have developed. And when it comes to this, I mostly mean scientific development. So basically a lot of work with data, acquisition, interpretation, and so on. So we would like to see services that help us manage our data. A lot of the work that we do on a daily basis has to do with harvesting data, storing, sharing, transferring, everything about this, but also data analysis. For data analysis, we mostly work with Python code, so then tools like Jupyter Notebooks are excellent because we can combine the software, the code, with documentation that can guide any user, any researcher, any student through the process. We also wanted to see how we could make use of services like virtual machines, or what basically Sandra just showed, that could support us not only in research, but also in education. So there are examples where, well, we would like to set up, for example, maybe in the future, be able to set up like a virtual machine, then give access, set up a short course, like a training module, and allow our students to play while learning both the science, but also the technical bit that has to do with the work that they will do in their research. Enough about, well, the theory. Let's see what we did. So I have divided this demo in 3 steps. There are 3 parts. Each one of them is executed at a different location by a different person. We will start in Thessaloniki, my earlier alma mater, Aristotle University, where my colleague, the PhD student that we have in the group, he has used his code, he has experimented with the Jupyter Lab, and, well, he has pre-recorded the video with his voice, so for the next 2 minutes, you will hear his experience in this video. I hope it works.
Hello, my name is Vasilis Anagnostou. I'm a PhD student in seismology at Aristotle University Thessaloniki, and in this short video, I'm going to demonstrate to you how to create and run an interactive notebook, in our case a Jupyter notebook, through the EOSC services. First, after logging the platform, we go to the Interactive Node tab and choose a server. In this case, I've already chosen the medium-sized server. We can see here some info on the size, the processing cores, the RAM size, as well as the cost of the server in terms of credits according to the EOSC credit system. Clicking View Externally opens a new window to the Jupyter Lab environment. Here we can upload files and notebooks, manage language servers, kernels, etc. And clicking a new launcher right here, we can see that it opens the launcher menu for notebook creation, opening console, and other useful tools such as creating text files. For this demonstration, I have prepared a simple notebook for fetching seismic data plotting them on a map, and saving them as TXT files. In the first block, we can see the important libraries needed for the notebook. The second block handles data downloading, choosing the appropriate client, defining time windows and region, while also creating some basic info on the catalog. The third and final block handles map creation, defining map parameters, boundaries, and various map elements, ending the notebook with a simple map of the study region, the fetched events plotted on it according to their magnitudes, and an export of the magnitudes as an example of said events as a TXT file to then be shared and used by other researchers and users. This is the map. And we can see here that the TXT file have been created containing said magnitudes. Thank you.
Thank you, Vasily. I don't know if you're online. So yeah, that was his experience. So a PhD student that basically knows how to do his work on his local computer, and now he gets access to cloud services. There was a reason I asked him to actually produce this output in a TXT file, and I will show you in step 3. But first we go to the second step.
Hello.
No, we heard you. Yes. Now we go to Athens. So the second part of the process was executed at the University of Athens. So again, we have a Jupyter Lab case, a different notebook, different region, basically, to work on the cloud. So we don't have Angelos' voice, but I will explain to you what you see in this next video. Great. So Angelos is in his own workspace, so he has opened the Jupyter Lab, and he has the notebook that basically harvests a database that is, it can harvest remote databases, but also at the local institution, because it uses Python libraries that utilize APIs, so these databases are completely open. Don't get me wrong, I'm not saying this is the best practice, I'm just saying that this is the case. So he can get the data, which are in this case waveforms. This means that they are continuous time series. So he cuts parts of these time series that come from instruments, seismic stations, and then he can run the code, which, well, depending on the data, of course, it can be quite demanding, because then the part of the code that we call automatic picker needs to go through the time series and basically make the process that used to be manual a little bit faster and locate the earthquakes, identify where the earthquake was recorded in the instrument. So after that, what Angelos did was to share basically this file also with me. So with this, we go to all the way up to Lund, where I'm sitting at my desk, and I have put my research hat, which I don't use very often nowadays. And I was waiting for the guys to finish their work and then see how I can basically produce the final part of this small workflow, which includes the output of this process. So for this reason, I have used the file share system and the Jupyter Lab. If we go to this video now, so I enter my my workspace. So by the way, I was authenticated super easily, like at least for my account with the credentials from the university. It was a very smooth process. And I can go to the file share. First, I use this service. I prefer to open it externally, where I can see the files. And of course, I don't have to log in again. It's all single sign-on, so I'm authenticated and authorized to get access to these folders. Here I have my personal folders, but I also have the shared folders over here, where I can see what the guys have shared with me. So basically, I check the TXT file that the first demo showed you. When I go back to my workspace, I'm ready to start the server so that I can run my notebooks. So at the Jupyter Lab again, I have access, obviously, to the same folders that I have in my file share system. So I can see this was the demo from the notebook from the second demo. This is the file from the first demo. So everything, I have access to everything because the guys have chosen to share those files with me. And in this case, I used the TXT file. Well, I just did it so that I can show you a different way of running, of using basically the service. But of course, I can also use the Python libraries that utilize the APIs that give me direct access to a database. That would be another process. So I have my notebook. This is a code, a software that I developed when I was working at the data center, which I have fully documented, and I use it for statistical quality control of data sets. So I'm ready to run the notebook and read the data file that Vasilis has shared with me. In this case, the data set is relatively small, so it takes really only a few seconds to run it. But I have tried other data sets, and I can give you also numbers because I wanted to compare how it responds compared to my local computer. My code also saves the output as a PNG file, which I can then go to my workspace, and I can find it on the folder that I just used to run my notebook, and I can share it with Vasilis because, well, he gave the input data, he deserves to see the result. I can also choose what he can do with it, so this is the case now for the sharing, and then I can go back to the file share system. Yes. Here in this case, well, I can see again the file, the folder where I was working, and I can see that, you know, I have already shared the PNG file with Vasilis. Everything is, you know, the systems are interoperate, so I can see the same information in any version of the workspace I choose to work with. And then I decided that, okay, well, I'm happy. I want to complete this part of this small research process that we had, which was basically in total it took a few minutes after we familiarized ourselves with the system. So I saved the notebook as a PDF because now it has the code, the instructions, all the documentation, and the results that we produced with the notebook. I upload it to my file share system, and then I can easily share it with my colleagues, and they get access to it, and that's it. So as I said before, I tried, I did several tests with at least my part of the process because I can test it with different sizes of the data set. So because of the fact that the code has some iterations, so we have Monte Carlo basically, these can be quite demanding. So when I tested it on the cloud, it took 4.5 minutes for a specific size of a data set. For the same data set, on my local computer, it took 6.5 minutes, plus 2 hours that it took me to set up the right version of the Python and everything, and everything else. So yeah, it was super smooth to just go, put my notebook there, and just run it. And it was the same for the guys that were using the Python libraries. So the next steps, at least for the current environment, for this, the first version of the node, we would like to complete the test that we started with virtual machines. Unfortunately, I cannot give you a demo today, but we would like to continue trying. Also, after we saw what Sandra has done with her team, basically we have like similar goals in a different domain. We would also like to estimate how expensive it is to use the node in different processes. I mean, we have the same questions as everybody else in this room and in the other rooms as well, right? So Spiros has explained several times that this is for demand management and so on, but what we care is if we have enough credits to run, basically to use the services, and where we should decide, like, this is the right place where the node can help us. Of course, we will follow also all the updates of the platform. I mean, we look forward to new features and also functionalities. And more into the future, so this is like the very next steps, but for the future, our expectations basically from the node is, well, to see the providers, the service providers, collecting user requirements, not when it comes to technical, but only those demands or expectations. We would like to see what is the plan, like to get bigger storage, for example, because what we have right now is sufficient to run like everyday work, but we cannot use it for storage. So, and of course it depends on the purpose, because someone might say that the EU Node is not a repository, and that's fair enough. But we would like to see what is the plan there. Also the credit system that we mentioned, and you know, maybe we can start collecting like wish lists for features and functionalities. We have many. And we would also like to see how the node and the service providers are going to investigate further the interoperation of systems. So yeah, as I said before, in our cases, we took the easy way, and we used databases that are completely open. This is not the case for everybody, right? And now I remove my research hat, I put my Envy hat, and I say that we have infrastructures that basically can allow us to take data from them, but you need to follow like to accept licenses, you have to be authenticated and authorized in order to get access to their systems. Then we have also interoperability issues when it comes to metadata, vocabularies, etc., etc. So we would like to see how the node will work towards meeting all of those systems, like the Envy Hub, for which I work in the Envy cluster. And of course, we are available to contribute to the continuous feedback from the community, because that's the only way we can actually co-design what we want to what we want the European Open Science Cloud to be. That's all from me. Thank you.
Thank you so much, Angeliki. And now for our next, third, final panelist, and then we go to QA. Ivan.
Yeah, thank you very much for inviting me for this talk. And yeah, it's the last day of the conference. So I think some of them have heard a lot. I hope a lot of nice things. I've heard also a lot of nice things, like making researchers happy. And well, that's a very rewarding thing to do. And I can recommend it to anybody to do it. I also heard, yeah, that EOS thing that can become quite large. That's nice. And well, if it becomes large, then you probably need to federate it. I agree. And somebody also said, if you federate it, you run the risk of becoming a worldwide ecosystem. Awesome. But let me take you down a little bit, down to earth. Every big thing starts with a small thing. And I started 5 years ago at SURF as head of the cloud team at SURF. And when I came in, we had a lot of consultants working directly with researchers, creating stuff for research, all custom made and not very replicable. Hardly reusable. So with my background, and maybe I need to explain a little bit about my background, I used to work with infrastructure as a service services for system integrators that would deliver IT services to middle and large enterprises in the Netherlands. I would design networks for large corporations which were better than any singular telecom company could make in the Netherlands. So scalability was sort of in my genes. And we created virtual desktop infrastructure for 13,000 users, where they would all have the same desktop. And we had self-healing things, that if things tend to go wrong, it would heal. And if not, it would go back to a mandatory system, and we can serve with a couple of people 13,000 users. So when I saw this, the first thing that I did was create a small team of developers within my team that could create enterprise-grade software. And And I have to say, I have a really great team. It's an honor to work with them. It's been a real journey. They explained to me that researchers don't need 24/7. But if they use it, it needs to be blazing fast. And researchers don't want the same desktop as the other researcher. They want a totally different one. So if you're going to create services, you need to have some building blocks. And we started designing things more like a Lego system. So our consultants could reuse things. And they could even make things faster, more efficient for the researchers. So the researchers would have less time to create these environments. So their time to research would decrease. So they were quite happy. And they started using our system, and more came in. And then these institutions in the Netherlands said, well, that's a handy tool. Can we use it as well? Yeah, but we have some requirements as well. We want to have a management board, and we want to have this feedback, and we want to have an API. And we said, well, if you pay us, then we can make it. They said, well, okay, we'll give you some money. And then we added some enterprise features to the system. And then these research communities came in and said, well, we just got this grant here, and we need to design and build a research infrastructure, but you already have parts of what we need, so can we just use it? And maybe add some things, and maybe maintain some of the Lego blocks that you built, because they're very important for us. And we said, well, that's really nice. We'd like to cooperate with you. And then these researchers came to me and said, well, there's one problem. If we do an international project, we are always paying the bill, because we start our system on your system, and we invite other researchers from around the world, and they're basically using our system. Can you not make something that they can pay the bill, so they can log into our system, and then we can use it as well? And then I said, no, I cannot do that, because our infrastructure is a national infrastructure. So it's only for Dutch researchers. But then EOSC came along, and I said, well, that's a nice thing. There, every researcher can log in, have some resources, has credits. So this could work. But now we have to bring it together. And then it's kind of seeing, okay, how will that fit? Because already thousands of researchers are using our infrastructure, and now EOSC is coming along. And how will that work together? So we made some small videos to see how we can do that. Because basically we use the same underlying infrastructure. We use also the Seant AI infrastructure. And this is the dashboard that our researchers see. But there's a little tiny difference. Because if you make a group or a collaborative organization, as it's called, in the EOSC, it's on the EOSC organization. But this one is maintained by the institute, so by the university. So they're full in control of their own user management. And they have procedures that if you are a researcher, you become admin in the system, and then you can invite people. But it's all within the process of the university itself. So if we skip a little bit along, we go to a group. I'm a member of a lot of groups here already. And here we can see an overview of what is happening here. And I can go to the members. And here it should stop, hopefully. So you can see I have invited as an admin of this group already a lot of people. So if I'm first log in, I'm the only one in here. And then I can add people and make them also admin, because sometimes I'm not there, and then somebody else has to solve the problems. And then we can continue. Normally I do a live demo here, but now we have to go to a video. So then after I've created a group of people, I can add application to it. So I can add the Serve Research Cloud to this group. But wouldn't it be great if we could also add an EOSC service here. So then Research Cloud could ask, okay, are there any other services in this group? Oh, there is, if I allow it to see it, then I can see there's an EOSC service in there as well. And then I could kind of federate with the EOSC service as a service. That would be very interesting, as I show you later. Let's continue a little bit further. You can also make some groups here. So for instance, if you want to have more elevated rights in Research Cloud, you are a developer, you can change catalog items, software in it, or you can put somebody in the no X apps group, and then he's only allowed to run some whitelisted applications in there and no other applications as well. So there could also be some groups here with EOSC in there, that EOSC has some things that they use to authorize, and that could work together. I think I'm finished with this video, and then we can go to the next one. But this is the desktop of the researchers in the Netherlands, so they can log in to Serve Research Cloud. They will see 3 action buttons. And one is a wallet, and I will explain a little bit later. So the wallet is not a credit. The wallet is something that can contain credits, but you have to have one to fill it. Let's continue a little bit. Then there's the create new storage. So a lot of researchers use a persistent storage disk, which they can connect to all kinds of virtual machines, which is quite handy because you start with a small VM that doesn't cost as much credits, and then you couple your large VM when you want to do the real analysis. And then we move on a little bit. And this is where we can create a workspace. And then down below in the screen, if we continue, you will see some of the workspaces that are already running in one of the groups that I'm a member of, and you can access them with an access button, the same as in EOSC. Now, let's continue and start creating a new workspace. Oh no, sorry, I go to the wallet first, I promised that. So I have multiple wallets, and this Seant wallet consists of multiple budgets. So this budget will allow me only to run on Azure. And it has given me 10,000 credits, and I have some remaining, I've used some, but this is linked to Azure. And I have another budget in my wallet, which can be spent on our own HPC cloud at Serve. Also there is some usage. But it would be nice if the EOS budget would be in my same wallet, because then I can start things within the EOS environment from here. Now let's continue. And I will show you something about my profile. Because in my profile, there will be other services that I can access, especially the, for instance, the sharing services. So here I go to the profile of the same EOSC group. I can see the members that are part of it. And I can access services. So, yeah, it's WebDAV or any other connection to OwnCloud. And EOSC also has the same backend infrastructure. So we could switch EOSC Sync and Share on, and every virtual machine that we will deploy will automatically be linked to the data that is stored on the EOSC environment. So that might be very handy to have. Let's continue. I tested it, it's not working yet, but we'll try to fix that. So now the next thing that we're going to do is to deploy a virtual machine. And that's a simple wizard where we go to create workspace. We select the group of people that we want to work with. And that's the same group. And then I have to say, okay, from which wallet do I want to pay it? and then I need to select an application. So there are multiple applications in there, and we work closely together with the researchers, so they maintain some of these applications themselves, or the community maintains them. Let's choose also a Jupyter notebook, because that was in the other example as well. And now you see that because I have budgets for these two, I can only see the deployment on Azure or on our own infrastructure. But if I would have this budget of EOSC in there, we could place next to this also a EOSC infrastructure where I could deploy it. So that would be very nice. Let's continue. Oh, I choose our own environment. I choose a machine. And then I can see what I've chosen. And here I can see what costs there are. They're also in credits here, so I can see what the daily usage is. So the basic systems are pretty much the same, so it should be easy to connect all these things. I give it a name, host name, and yeah, Research Cloud is a little bit deploy and destroy. It's easily to deploy something, so we say, well, normally after 5 days we destroy it automatically. You don't have to worry about it, but you can also place the date in the far future and keep it running for longer. So submitting that information, it will start deploying the virtual machine, and that could be on AWS, Oracle, our own environment, and also EOSC if possible, if you have the budget. That should be very flexible. And yeah, if it's done, you can press the exit button and you get into the same Jupyter environment. And if everything goes well, you have some files there. And if it's all linked with sync and share to EOSC, you should have maybe your research drive and a web dev mount to EOSC as well in our environment. So a lot of options to work together. I think this was the end of the second video. And now I showed you the login from the Surf Research Cloud side, but the same should be possible, I think, from the EOSC side. So if I log in from EOSC, I should be able to see the Surf infrastructure and maybe use Surf credits, because I'm a Dutch researcher, I'm allowed to. And you say, yeah, but then we have a lot of credits. We have the Dutch credits and the German credits and the EOSC credits, and do we need an exchange rate for that? No, we don't, because the German credits can only be spent in Germany, and the Dutch only be spent in Dutch computer structures, and the EOSC only on the EOSC. So there's no need for an exchange rate there. We'll keep it live very simple. I can also imagine that if I can log in through EOSC or through our Dutch portal and have the same experience, the Dutch portal can be down and I can still work. So you have a very resilient infrastructure. So if some country gets bombed, which unfortunately happens, then you could have some extra capacity in Europe where researchers of other countries can log in and you can still work together. So a federated infrastructure can be very resilient, can be very flexible, and will make the request of the researchers that I have possible. Because I have researchers that need to do research on rare diseases, where they need data from other countries, which they're not allowed to get. So if you have a trusted research infrastructure that allows them to run easy jobs in different countries, that would be very helpful. Also, the social sciences, they use the Bureau of Statistics data. They have to fly in an airplane to another country to do their research there, and the infrastructure there is not good enough to handle their algorithms. So I think this whole thing will be awesome sometime. Thank you.
Now, thank you for your patience. I'm going to invite Sandra and Angeliki to join us over there. It's time for questions, right? And we can start with questions from Slido. We can start from any questions from the audience. And I already see a few hands. I see many hands. Okay. Do we have someone to help us with a microphone? Okay, that's great. Thank you so much. So I'm gonna let you decide who gets the microphone first.
Now we're going here.
Please just remember to introduce yourselves.
Okay. Hi, I'm Anka Hienola from Finnish Meteorological Institute, and for the first time I will not complain. I have to say I'm actually excited that what I have seen, and I really hope that the service is at least as good as the two excellent presentations painted it. Yes? So, great job. Great job. This user environment, it was exactly what we thought of when we were working in EOSC Future, but we didn't get to that far. So it's really cool. Thank you for the presentations. Really, really awesome. I would like to ask you, how many credits did you use for that? And then I would like to say something else after they finish.
Definitely, yeah.
Maybe I can start. We didn't use too many credits, actually. The services that we used were between the small and medium size, and after we got testing, which took maybe a day or two, we started immediately copying data and doing our executions. So yeah, maybe if we use something like 50 credits or something like this in total, and only because we kind of, there is a bar that says for how long you want to have this taken. And well, we said, okay, let's say, I don't know, 10 days, because we don't know how much it will take. So that was our first approach. But most of this was still there. So we didn't use it completely.
Same for us, actually. I mean, we started with the minimum that it costed to start the servers, and I have not used all of these credits yet, like the initial 30 credits, basically, from the total. Yeah, they are still there, because we use only the Jupyter Lab and the file share system, so those are relatively cheap.
So I was wondering if one has like a heavy computation, might be so that 500 credits is not enough.
Yeah.
Then we probably have to think of a more flexible way of giving credits.
Definitely,
But
yeah.
this will come in time.
Yeah, this is definitely a possibility. We can think of workloads that are quite intense. There is also the option of contacting the help desk and requesting extra credits if there is spare capacity to provide.
Okay, so now I would like to say whatever I had to say. So I'm super excited to go back to my institute to present the entire EOSC, but I have a problem. No, I'm not complaining. This is something that I'm sure, I'm sure it can be fixed, but I prefer to say it in public so that it's fixed faster. As of now, the entire every single researcher in the Finnish Meteorological Institute has exactly 0 credits, and we don't know why.
We can tell you why.
Okay, then it's fixable.
So it's definitely fixable. The policy right now is a researcher gets 500 credits if they are a faculty in their organization. They also get 100 credits if they're a member of the staff. So if for whatever reason this information, the attributes, is not available in the identity provider of this organization, this is not transferred to us. So the best way, and what everyone should do, is contact our help desk, and this is where we notify through XANT, the WAI, the home organization identity provider.
Okay, awesome. Again, congratulations.
Thank
It's
you.
really exciting.
Okay, next question, please.
Yeah, hi, I'm René Belso from the Danish E-Infrastructure Consortium. I'm sharing the excitement of my colleague. I think you've done a fantastic job, and I look forward to getting into this. So about the credits, you say there is no need for an exchange rate. And well, I would tend to disagree, because what if I would say I will give you my EU Node credits at rate 0.5 for your Dutch credits, and I don't mind, I can only use them in Netherlands. We do need a transfer rate, and we do need a cross-border economy to get this thing going. But let's leave that. It's just a kind of a question which you might respond on. In terms of the credits, I represent the infrastructure provider nationally, and we would love to test this in depth. How do I do that with 100 credits? No way.
Again, for testing purposes, I would suggest going to the EOSC EU Node, joining the technology forum. There is a request form over there, and also getting in touch with us. Specific inquiry, I am from the industry, I'd like to test and do things. Yes, please.
Okay, great. Thank you.
Yeah, I would like to respond on the credit part. I have run a very agile team, so we take it step by step. And at the moment, even if I use Azure infrastructure, it's being paid by the Dutch tender part of the OCRA framework. So all these things that we deploy are based on contracts that the Dutch government or Dutch SURF has with all these parties. And I think in the Danish situation, it is the same. So I would like to stay with this model first, and then if an exchange rate is needed, let's move to the Euro identity wallet at some point and fix it in 4 or 5 years. That would be my suggestion.
Thank you. So, hands over there.
Hello, Raphael Ritz from the Max Planck Computing and Data Facility in Germany. And first of all, congratulations on what you've achieved so far. In the context of the German national data infrastructure, we are also currently in the process of identifying and setting up basic cross-cutting services through which we also envision to provide resources. And we are facing exactly the same problem that you've been outlining and addressing with this credit system. And my question is now more with respect to reuse. First of all, I would assume that the way you've realized this technically as well as to a certain extent in terms of governance, we can happily reuse if we see that fitting for us, right?
Definitely, yeah.
And but once we get there, then I think we should seriously think about whether it's exchange rates or it may require some agreements in the end, but I think if we would keep the national silos, that would defeat the EOSC Federation purpose. And I almost foresee that we are going to be, people will expect from us, for instance, to accept the credits that you've introduced on our side. Whether we can agree on doing that and under which conditions is a question we need to answer, but I would expect that to be doable.
Yeah, if I may, I'd like to mention 2 things. The first is the entire output of the EOSC EU Node, the architecture, the software is open source. And as contractors to the European Commission, we are also required to support whoever has questions for this. So we'd be happy to help. About the second part, about the credits, the exchange, etc., I'd like to take a step back and just focus on the important thing, which is when a researcher, a group, a project has credits, whatever, funding, they have resources that are virtual machines there, storage there, containers there. The important thing is that because we use open standards, they can pool these resources, technically, wherever they are. So it doesn't matter if we have credits or not. It really doesn't matter. And the important thing is that the bottom line, the services themselves, are interoperable in this sense. Next question, please. Yes.
Hello, thank you for the presentation. Maria Rita De Luca from Italy, from Area Science Park, which is a research center building 2 digital infrastructure in material science and life science. And my question is about the policies. So now we saw two examples in which the data were quite small in volume. What about if I have a large volume of data? For how long can I still use the storage of the EU node? And what did you decide? I don't know if it is in the policy or in some other decision. Thank you.
So the current policy is also available in the website. So essentially, the file sync and share service right now, the limit is 50 gigabyte. It will change. And you will see that the cost of the service per month is actually quite low. This means that essentially any researcher can continuously have access to the repo functions as long as the EOSC node is there. Next question, please. Yes, on the back.
Sorry, can I respond a little bit? Because data is very important. And in the Netherlands, we have still contracts with the institutions where the researchers work. So when the credits run out, we stop all machines, but we never delete data. And we have a contract that we can always charge for the data afterwards. So we try to reduce cost as much as possible, but still data needs to be preserved. And maybe that can be a policy for EOSC as well.
Thank you.
Yeah, Carsten Heuer-Klick from the German Aerospace Center. I have a little bit related question. If I start sharing data in the sync and share, do they have persistent URIs, which I maybe can reuse in metadata, linking to the data or publications or whatever? So,
this is an excellent question. Currently, no, because it is meant as a cloud storage service. Getting persistent URIs means providing a publishing flow, essentially, right? So this is not currently there, but is an excellent suggestion for the future, yeah. We can have a few more questions, please. So if there, yeah.
Thanks, Martino Romagnello, European Southern Observatory. Congratulations and all. This is really, really looking very, very good. A tiny detail. So you mentioned faculty, but what about students and postdocs? How should they be qualified in this?
Excellent question. The policy is clear. We give automatically credits to faculty and staff. We know, of course, we have projects with undergrad, postgrad students, etc. The idea is the faculty member gets the credits in their wallet, reserves resources, storage, VMs, and then he can share the resources themselves, access to the virtual machines, access to the storage, etc. So they can work as a group. There is a group function. You can invite users that have 0 credits, and when you create a group, you get double the credits. Exactly for this reason, in order to support these collaborative functions.
Spiro, everyone is happy now.
You were not supposed to reveal this.
Can we have another question over there? Yeah.
Thank you. Ulrich Bundke, I'm Technical Director of the NW Hub Next. So we are a potential node. So, and I want to stay with the credit point system a little bit, because what researchers really hate are borders. These are no good. And what we and now as a potential node, so we have lots of credit systems in each node. Everybody can do whatever they want. This is not a good concept. We have to have an exchange rate, we have to exchange, we are cooperating, we are a federation. If we are in Germany, we are a federated one, but we have one currency. And it would not be a good idea to have Hessian, Bavarian, North Rhine-Westphalia, euros, no, not good. Even euros, we are European, so we have one currency there. So we have to have a solution for that. What is a potential solution for this, in your opinion?
Yeah. So as I'd like to make clear that the concept of credits, how they are introduced, how they're used in the EOSC EU Node, is not something that we expect or is expected to be transferred. We heard yesterday that it is yet another model to consider, right? regardless of the credits, the question is access policies, who has access, and why? Because I am Spiros, because I'm a member of a community, of a member of an RI, and who pays for this? So it doesn't matter if there are credits or not. Again, harmonized access policies and who pays is the main question that is still unanswered. I agree on that.
Yeah, I can respond to that as well. If you look at federated learning, I expect that we have to run a job in multiple countries at some point, and you have to have a micropayment system to do the billing on that. But I don't think the technology is there yet. So I'm hoping the EU identity wallet can provide something like that. I know the Nobit in the Norwegian countries are working on something similar. I'm hoping that there will be a standard for that, and then we can implement it.
We have time for one more question for the audience, unfortunately, but you can meet us out there at the booth. So, you?
Hi, thanks very much. My name is Jenny O'Neill from HEANet in Ireland. We're the mandated EOSC organisation for Ireland. My question is slightly different and it's more about outreach. So we have these really amazing resources which are now available to researchers. What is the plan for telling the researchers about it? What's the outreach plan?
You mean in terms of communicating these services to the entire community?
Yeah,
right?
making sure that researchers are aware that these resources exist.
Yeah, this is where the EOSC EU Node is provided by the EC, and through the EOSC Association and the community channels, we reach out of them. So the short answer is the EOSC Association. So with that, and let me see if there is a question we can have right now. I will take the first one. I would advocate for giving some categories of support staff, IT, RDM support, some more credits as they're the forefront of promoting these services. Opening a small parenthesis over here, you can get in touch with the EOSC EU Node. Let us know. We are an organization, 20 people, we are an RI, or we're someone else. And we would like some resources, compute storage, to do X, Y, Z. It doesn't matter, right? Get in touch. There's always the chance that it's spare capacity, spare resources, so we can help you, however way we can, right? So think outside of your individual researcher hat, and also as an organization, as an RI or whatever. With that, right now, I think we have reached the end of this session. I would like to thank our panelists, especially for the hard work. I would like to thank all of you for joining us. Thank you for your kind words. Our team is really happy to hear these things. And hopefully we're going to see you again in the future. Thank you.